For this lesson, we're going to be going over how to multiply and divide rational expressions. So let's quickly start by reminding ourselves how to multiply and divide fractions. So all of the underlying principles of when we're multiplying and dividing rationals are the exact same as when we're multiplying and dividing fractions. So for example, if I were to multiply these two fractions here, I'm just going to multiply straight across. So now I have A times C all over B times D. Similarly, when I'm dividing, I'm just going to flip the second one and then do that multiplication. So I have A over B stays the same. I switch to a multiplication sign and I flip the second one. And now we're exactly where we were before. And I can multiply straight across. So I get AD all over BC. So those are the two rules that we have to remember when we're multiplying and dividing fractions. So let's start with some multiplication examples. The first thing that we're going to do is we're going to factor the numerators and denominators if possible. Next, we're going to divide out any factors that are common. So in other words, we're going to cancel things out. Then we'll multiply the numerators and multiply the denominators, and then we'll write as a single rational. I'm going to add in one other thing here, is that we also need to find our restrictions. These are very important because without them, our expressions could be undefined. So it's very important that we write our restrictions. Okay, let's start with one that you guys have actually done before in grade 10 because it's just simplifying our exponent laws. So for this one, let's start by multiplying straight across. So we can simplify first, or you can multiply straight across first. It's up to you. Let's try multiplying straight across first. So now I just start by multiplying my coefficients. So 6 times 15 will give me 90. And then I have x cubed, y cubed. And then I'm going to divide by 5 times 9 is 45. X times x squared is x cubed. And then we just have a y. So now I'm going to take a moment to look at my restrictions. So if I look at the bottom, I can't have that equaling 0. And that could happen when my x is 0 or when my y is 0. So those two things cannot happen because we can't have a 0 on the bottom of our fraction. Now let's simplify. So we'll start with the coefficients. So 90 divided by 45 is 2. And now I look at my x's. I have 3 on the top and 3 on the bottom, so those cancel and go away. And now for my y's, I have 3 in the numerator and just 1 below. So that leaves me with only 2 left. So that is my final answer. Let's try another one. So for B, we have 2a plus 6, all divided by 7, multiplied by 3 divided by a squared minus 9. So the first thing we're going to do is look and see if there are any restrictions that we can worry about right away. Right now, there's nothing too clear, so that means we have to start factoring. So I'm going to start by looking at the numerator of the first expression, and I can common factor out a 2 here. So I'll take out that 2, and I have a plus 3 all over 7. And now for the other one, I have 3, and on the bottom there is a difference of squares. So that would be a plus 3, a minus 3. Now, it's up to you. We can do the multiplication right away, but a lot of people like to start crossing things out here, so you can do that too. So I have an a plus 3 on the top and an a plus 3 on the bottom, so those can go away. And now I write what I have left. So I'm going to multiply straight across. So 2 times 3 is 6, and all of that is over 7, a minus 3. Now, the last thing I need to do is I need to make sure I've written all my restrictions from all of the steps. So I look, and there's one here and one here. So those will give me that A cannot equal -3 or +3. And that is my final answer once I have those restrictions written out. Okay, let's try another one. So this one is a little bit more intense. So the first thing I do is I see if I can find any restrictions from the get-go, and I can't. So I'm going to begin factoring. Now the factoring here, there's a lot of it. So I'm going to go through it nice and slow if you need some reminders for factoring. So let's start with the numerator of my first term. So I have 2x squared plus 5x plus 2. So I need to find two numbers that add to 5 and two numbers that multiply to a times c, so 2 times 2, which is 4. So in this case, I have 1 and 4, 1 and 4. So because 1 and 4 add to 5, instead of writing 5x in the middle, I'm going to write 2x squared plus x plus 4x plus 2. And now I'm just going to factor by grouping. So I factor as much as I can out of these two groups. So if x, 2x plus 1, and I can take out a 2 of the other one, and I'm left with 2x plus 1. Next, I take that 2x plus 1 out of both terms. I'm left with x plus 2. So that is what goes on the numerator of my first expression here. 2x plus 1, x plus 2. Now let's do the denominator. So for this one, we have 4x squared minus 8x minus 5. So I first check if there's anything I can common factor, and there's not. So I need two numbers that add to the middle number and two numbers that multiply to the first number multiplied by the last number. So that would be -20. And if I think about what those numbers are, I will have -10 and +2, -10 and +2. And now because I know that those two numbers add to -8, instead of writing -8, I can do -10x and 2x. And now I just factor by grouping. And it doesn't matter the order you put that -10 and 2 in, it'll work itself out either way, which is great. So I common factor as much as I can out, so 2x, and I'm left with 2x minus 5, 1, 2x minus 5, and then I can take that 2x minus 5 out, and I'm left with 2x plus 1. There we go. So now that's what goes into the denominator over here. And now let's continue our factoring. So next one is the numerator over here. And if you're comfortable with this stuff, you're more than welcome to kind of fast forward, or if you want to slow it down even, you can do that. So for this one, we have 2x squared minus 11x plus 15. So I first check to see if there's anything I can common factor. There's not. So I need to find two numbers that add to the middle number, two numbers that multiply to the first number times the last number. So that's 30. So now I think of my numbers that add to multiply to 30 and add to 11. So I have -5 and -6, -5, -6. So that will give me 2x squared minus 5x minus 6x plus 15. Now I factor by grouping. And that is what goes in the numerator of my second expression. Okay, one more to do. So this last one we'll do in blue. And I'm just going to do it over here because I'm running out of room. So we have 3x squared plus 7x plus 2. And that will give us two numbers that multiply to 7, and two numbers, sorry, that add to 7, multiply to 6, 1 and 6, 1 and 6. So 3x squared plus 6x plus x plus 2. Factor by grouping again. And we're left with x plus 2, 3x plus 1. So after all that factoring, I can put that over here. Okay, so we can multiply right now, or you can start canceling, whatever's more comfortable for you. So let's see, I have an x plus 2 on the top. I have another one here. I have an, oh, sorry, I have a 2x plus 1 and a 2x plus 1. 2x minus 5, 2x minus 5, and that is it. So we're left with x minus 3 over 3x plus 1. Now the last thing we have to do is find those restrictions. So I look, and I have restrictions coming from here, from here, from here, and from here. And those will give me that x cannot equal negative 1/2, 5 over 2, negative 2, negative 1/3. And that is our final answer. So that is really as hard as these get. Now let's try some division ones. So the steps for dividing are really similar. The only real difference is we need to flip the second one and then multiply. So sometimes we get a few extra restrictions from that, so just be really mindful that you've got all of your restrictions. Okay, so for this first one, we have 4a minus 8 over 11 divided by a squared minus 4 over 7. So let's first try to factor out as much as we can. So if I look at the numerator of the first one, I can factor out a 4 there, all over 11. And that second one is a difference of squares, so I can factor it nice and quick. And now because we're dividing, we're going to flip the second one and multiply. So we have 4a minus 2 all over 11 multiplied by 7 all over a plus 2, a minus 2. And you can put them together or you can cancel out here, it doesn't matter. So I have a minus 2 and a minus 2. So 4 times 7 is 28 all over 11 a plus 2. And that's it. Let's finish by stating our restrictions. So if I look, I have these two here, which will give me my restrictions. So a cannot equal negative 2 or positive 2. And that is our final answer. Now we're going to be working on this last example. So to start, we always look to see if there are any restrictions that we can see right away. In this case, there are not any restrictions we can see right away, so we need to factor. So just as some practice, I'm going to go through and show you how to factor these nice and slow. So let's start with this one up here. I'm just going to factor them off to the side so you can see exactly what I'm doing. So we have x squared plus 3x plus 2. So now I need to find two numbers that add to my middle number and two numbers that multiply to my last number. So in this case, we'll have 1 and 2, 1 and 2. So because my equation starts with a 1, I can just jump right to the brackets and do x plus 1, x plus 2. So let's write that into our equation over here. X plus 1, x plus 2. Now let's factor this here. So we have x to the power 4 minus 4x squared. So when we're factoring, we always start by common factoring out as much as possible. So in this case, I can common factor out an x squared. So I'm left with x squared minus 4. Now the stuff in the brackets is a difference of squares, so I can continue factoring. And I have x squared, x plus 2, x minus 2, just like that. So now I can write that into my equation. Like that. And let's just continue on. So my next one would be this up here. So I have x squared minus x minus 2. So I need two numbers that add to my middle number and two numbers that multiply to my last number. So in this case, that would be negative 2 and 1, negative 2 and 1. And because this starts with a 1, this whole equation, we can jump right to x minus 2, x plus 1, like this. So let's put that one into our equation. And finally, we have our last one. So we have 5x cubed minus 9x squared minus 2x. So the first thing we always do is we see if there's anything that we can common factor out. So common factor it out. 5x squared minus 9x minus 2. Now we're going to use decomposition to finish factoring. So we need two numbers that add to the middle number and two numbers that multiply to 5 multiplied by negative 2, which is negative 10. So in this case, that would be negative 10 and 1, negative 10 and 1. So now, instead of writing that negative 9x, we're going to use negative 10 and 1. And now we're just going to factor by grouping. So we separate this into two groups. So of x. Now we're going to factor out as much as we can out of each group. 5x, and we're left with x minus 2, 1, x minus 2. And now we can take that x minus 2 out, and we're left with 5x plus 1. So now we have that, and we can put it into here. We have x minus 2, and 5x plus 1. So now we have some more visible restrictions. So now let's look at all those brackets on the bottom and address the restrictions. So x cannot equal 0, plus or minus 2, or negative a fifth so far. If we end up getting more, we'll add those in as we go along. So now because we're dividing, we're going to flip the second one and multiply. So we're going to flip the second one. And multiply. All over x minus 2, x plus 1. And when we multiply, we just multiply straight across like this. And now let's cross some things out. And in addition to that, we also need to make sure that we're not missing any restrictions here. We have everything except that negative 1. That's another restriction. And now we're left with, oops, 5x plus 1 all over x times x minus 2. And that is our final answer. There we go.